I don't remember if it's these switches here.
There's the two. There you go.
There,
Oh.
like that.
For those who are online, can you hear us?
Yes.
Okay, thank you. So okay, hello everybody. Thanks for joining us today. So yeah, that's the third seminar of our seminar series with Dr. Kirkegaard. I believe most of you already know Dr. Kirkegaard, but for who still doesn't know Dr. Kirkegaard, Dr. Kirkegaard is a researcher at Australia, and he's in his sabbatical period here in Kansas State. So, and today, Dr. Kirkegaard will share with us a presentation about diversifying wheat farming systems with legumes and does it pay? So, Dr. Kirkegaard, please feel free to share.
Thank you, and thanks everybody for coming. It's a busy time for you guys here, and apparently there's a World Cup soccer game on as well, so I think it's very good to have you all here. This is a bit of an outline of my talk. I'm just going to go through a little bit about the history of legumes in Australian farming, then talk about some of the benefits in the farming system, why we're perhaps not growing more legumes than we could, some of my recent farming systems research, and at the end that'll be focused mostly on grain legumes harvested for grain. At the end I'll talk a little bit about cover crops and intercrops and some of our interest there, and then a little bit about the future. So that's kind of a bit of a rundown. Some of you would have seen this graph before. I kind of use it because it's just a really nice way to summarise what's been going on in the Australian dryland farming system. Wheat is the main crop, and so looking at how wheat productivity has changed over the years is helpful. The first point is that in the 1950s and 60s, we really sort of turned around that kind of plateauing of productivity with the introduction of lay pastures. So up until then, we were growing cereals, with fallow. Soil fertility was declining, erosion was going on, and the clover pasture lay system came in, where farmers would basically grow a period of clover pastures for 4 or 5 years, and then after a while they would plant that to crops using the fertility that had built up, and then they'd go back to pasture after a few years. So that was kind of a mainstay in that period. Unfortunately, well, not unfortunately, but what happened after that was essentially the price of wool declined. People intensified their cropping, they reduced their pasture area, and that was facilitated by the introduction of no-till cropping, and nitrogen fertiliser started to get used for the first time. And in a sense, legumes started to decline. I guess the pasture legumes certainly started to decline. And initially, although we did have some areas of lupin, it was canola that came in as the widely adapted break crop. More recently, it hasn't been necessarily legumes that have been driving the recent increase in wheat productivity, but legumes have been in there sort of facilitating all these changes, and I hope to kind of explain a little bit about that as I go along. So as I said, in the 1990s, we had this period of extreme sort of crop intensification. You can see here how the area of crops just really exploded, and the number of sheep just declined. So from 170 million sheep to 75, that stayed pretty constant. Now cropping is sort of still continuing, and you see the diversity of crops. Back here we only really grew wheat and barley, and then the diversity of crops has also increased over time. So farms were getting bigger, pastures were declining, no-till was kind of adopted during this period, and essentially, the labour efficiency was really, really high. Like, people were managing twice the area of land. People are now managing twice the area of land they were in the 1990s. So these were the changes that were going on in the farming system. Now, the challenge that presented for us is that essentially pastures were our kind of regenerative. This was regenerative agriculture, right? This was our regenerative phase. The pasture phase built fertility. We then used that fertility to grow crops. And so, after bringing that fertility from those early years back, you could get into this cycle of just maintaining the soil organic matter levels in a good state. And this was a very sort of sustainable system, and the sheep enterprise and the cropping enterprise gave the farm some resilience. So if you start to lose that pasture phase and move to no-till, one of the issues there is we've shown that in our climate, there's a lot of great things about no-till, but it's actually difficult in our climate to build soil organic matter with no-till. You can recover it from a bad state, but if you're coming out of a pasture and you move to no-till farming, you struggle to maintain soil organic matter. And you can see here, this study kind of was conducted before I started working, and you can see even in a loop and wheat rotation with all the stubble retained and a no-till or direct drill system, really you're just struggling to hold. That's a small gain, but a non-significant gain in in soil organic matter. So much better than burning and cultivating for sure, but it's not building like the pasture phase did. So that's our challenge. And you can see that if you look at this graph here showing this is the amount of nitrogen taken off in crops in Australia, and this is the amount of fertiliser nitrogen we've been applying. So you can see here, this big difference was all made up from basically pasture legume residues in the soil. And as they've declined, we've really had to lift the amount of nitrogen fertiliser that's being used. You can see here, if you look at how much legume nitrogen, how much is fixed, how much legume nitrogen do we think is fixed by different legumes in the system. So you can see this pasture phase here, it can fix 174. If you want to convert this to pounds per acre, just multiply by 0.9, okay, about 90%. So a little bit less than that. And in a pasture phase, pretty much all of that stays in the field, right? Same if you grow a pulse and you brown manure it. So BM is brown manuring. It's like a cover crop. You spray it out and just leave the residue on the field. And so pretty much that all stays in the field. But if you're growing a legume crop, it fixes a lot of nitrogen, but then you remove a lot in the grain. And so the balance can sometimes be negative, or it can be positive. But essentially, we've got a bit of a challenge there if we hope to replace pasture legume nitrogen with what we can achieve with pulses. And as I was saying before, as you sort of come down in fertility, so this is sort of soil organic matter declining over time with years of cultivation. Initially, if you do conventional management, if you switch to no-till with improved management, you still can't hold, you can't hold the soil organic matter at these high levels because there's just not enough carbon going back in. Once you're down at these low levels, you can lift it. And if you're really low, then no-till will get you out of that. But you can see that once pastures go, it's hard to hold this kind of decline. So that's our challenge. And as that happens, if you look at how much soil nitrogen we're relying on, or nitrogen coming from organic matter compared to fertiliser in 2017, and you project forward what will happen, basically we're going to be getting less soil nitrogen because of this decline. We're going to rely more on fertiliser nitrogen, and so the cost of that as a percentage of our total gross margin, goes up. This is for a soil in my area of Australia. If you go to some of the drier areas, it's a similar story, lower levels of nitrogen, but essentially as a proportion of what things are costing you, the nitrogen cost is going up. So that's the kind of challenge we have. So we do have, and we have had areas of profitable legumes. I wouldn't want you to get the wrong idea. In the 1990s, one of the first break crops to come into the system was lupin in Western Australia. We had 3 million acres in 1998. Unfortunately, that's declined significantly because lupins are used for sheep feed, and you can't make enough money out of lupins to pay for the high cost of herbicide-resistant weed management in no-till systems. So lupins sort of started to go out, and canola, which has a whole range of herbicide-resistant types, came in as a favoured break crop. Lentils have been really sort of increasing in parts of South Australia on alkaline soils where they're really well adapted. And in northern New South Wales, chickpea wheat is a very kind of common rotation up there. So there's pockets of Australia where certain legumes do very well and have been adopted very well. So farmers are quite irrational in their decision making. But what we don't have is a widespread, widely adapted legume like wheat is adapted widely, canola is adapted widely. We don't have a legume that we don't have soybean, basically. We don't have something that's as grown as widely as soybean. So we have to kind of select the legume. So just to look at current grain legume areas in Australia. So essentially the biggest area we have is of chickpea, and that's really grown in that northern area, summer rainfall dominant, that's a very successful and a very profitable, and has been for some time. So that's kind of that's a stable crop there. Not a lot of canola grown up there. They haven't really been able to adapt canola as well in that sort of northern subtropical area. As I said, we still have appreciable areas of lupin in Western Australia. It has declined a lot from its peak, but it's still there. Lentils grown in South Australia mostly and across into Victoria. Faba beans are in that kind of southeast corner, mostly New South Wales into Victoria and a little bit into South Australia. And there's pockets of field peas which sort of come and go, but are not highly profitable. But if you add all those areas up and you add what's left of our annual pasture area, I estimate about 1.1 million acres come out of pasture and go into crop every year. And you look at how much wheat, barley and canola there is, essentially all of those legumes are really only covering about 7 million acres. So less than 12% of crops, of non-legume crops, can be sown after all of those legumes in Australia. So that's why nitrogen fertilisers had to come in to sort of supplement what the pastures used to do for us in our system. And obviously we would like to get more benefit, as much benefit as we can, from the nitrogen provided by grain legumes, if we can keep them profitable in the system. This came out just recently, so looks like lentils are sort of going gangbusters with export opportunities to India and Bangladesh. So that's great. This area of lentils is probably going to keep increasing. But we would like to see, and especially in my area in that sort of southeast corner, on acid soils, we don't have the chickpeas, and the lentils don't grow so well there. So it's kind of either lupin, field pea or faba bean that we have been using. Okay, so legumes are great for supplementing that nitrogen fertiliser, taking the pressure off fertiliser costs. But legumes do a lot of other things in our rotations. So they're important for all of these different aspects of the farming system, and I want to sort of I want to work through these just slowly and show you some of the data demonstrating all of these benefits of them in the system, because often these get overlooked and sometimes they're actually quite important. So let's go to the nitrogen benefits first. What's the sort of level of nitrogen benefit that we've been able to measure? And so here, of course, we know that legumes, if they're well nodulated and healthy, and they produce a healthy, profitable legume crop, that legume crop can fix about 20 kilos of N per hectare. So, 18, 16, 17, 18 pounds per acre per tonne of above ground biomass. And then, that can lead to that can provide benefits into a following crop, be that a wheat or canola. And so I showed you this table before, just showing that basically, depending on the end use of that legume, whether it's a pasture, a pulse for grain, or a brown manured or hay, or you're likely to be able to get different amounts of nitrogen into the system. You can see how variable that is. It's extremely variable and very difficult to predict, but those averages give you an idea of what's possible. And as I said, with pulses, if you're removing that grain, you're down to reasonably lower levels going into the system, and sometimes it can even be a net loss. And different pulse legumes are providing different amounts of nitrogen to the system, partly because of, or mostly because of, the amount of biomass they produce. So something like lentils and field peas, very low levels of above ground biomass, so much less potential to fix nitrogen into the system, whereas something like faba bean or lupin, much bigger plant, much more biomass, and so if it's nodulated well, it can fix a lot more. And as you can see, if you terminate those as a brown manure, if you don't harvest the grain but you terminate them, then you can double that amount of nitrogen that's going into the system. And so here I've summarised a whole lot of field experiments done by different people over the years. And what it's showing here is how different crops affected the residual mineral N that was in the soil after they were harvested, and how that affected the following wheat crop. So you can see essentially, as the amount of residual N goes up, you're generally getting this increased response in the following wheat crop. And you can see in all cases, these lines are just linking different previous crops in the same experiment. In each case where there's a legume, the red dots, there's always more nitrogen, and there's generally higher yield than after either a cereal or a canola crop in the same experiment. So that's a sort of a summary of the kind of benefits we see. And it's the case globally. If you just plot the yield of wheat after wheat against the yield of wheat after a legume, and this is the one-to-one line, if there was no effect at all on yield, everything would be on this line. And you can see they're almost inevitably above that line, and they're above, and some of them are above that line quite substantially. So, and as I said, that's not only this nitrogen benefit, but there are often other benefits from the legumes, which I'll touch on. Now, that was all experimental data, but how are the farmers doing? So, you know, there's a lot of things that can go wrong with legume crops. And so this was a survey of 61 commercial crops sampled over this period of time, a range of different legumes. And we measured how much nitrogen they were fixing. And you can see the range was, you know, from almost nothing to fixing really well, an average of about 65%. So that means they're fixing nitrogen to about 65% of what we think, you know, was possible if they were nodulated well and the fixation was going well. The average was 90 kilos per hectare, so pretty close to those numbers I showed before, but a huge range. And the troubling thing, I guess, is that 20% of those paddocks had legumes that were fixing less than 50%. So if you're going to have a legume in that field and it's only working half time for you, it's like sort of driving your fertilizer truck around with nitrogen fertilizer just dribbling out on the road. It's just a waste of having a legume if it's not doing its job. And the main problems for us, you know, you can see legumes when they're not doing well. This is a faba bean on an acid soil. So anything that holds up the growth of the legume and reduces its biomass, any of these things can reduce that fixation. But also you can have soils that affect the nodulation, affect the rhizobium as well as the legume crop, and all of these things are contributing. So it's really important to have your soil, you know, in a good state so the legume nodulates and grows well if you want to maximise that benefit. This is a blatant plug for a paper that I'm a co-author of, but some of you might be interested in. It's a really nice compilation, global compilation of the input of nitrogen from legumes compared to fertiliser for the 10 biggest maize and wheat growing countries in the world. So this represents systems that are growing 80% of the world's maize and 80% of the world's wheat. And I thought it was just interesting to see, if you look at the areas here, so the US has got a lot of wheat and maize, but it's also got a lot of legumes, mostly soybean, I imagine. Whereas you look at Australia, like we don't grow much maize, all of this is wheat, but, you know, we have a pretty low proportion of legumes by comparison. So, you know, the capacity to satisfy the nitrogen requirement of these crops from these crops kind of varies around the globe. And it's just interesting to look. This is another graph from that paper. I'm trying to tempt you to go read it if you hadn't picked up on that. This is the amount of nitrogen used and the amount of nitrogen lost in this range of countries in wheat production systems and in maize production systems. So yeah, there's some really interesting numbers there, and it's a very recent paper. So and what Mark Peoples and his authors found is that in Australia, when you add it all up, how much we think is being fixed biologically by legumes, how much is being applied by fertiliser, they're about equal, like about 0.7 megatons of nitrogen per year coming from fertiliser, and that's matched by what's coming from it. So we're about 50-50. I suspect if your soybeans are doing a good job, you're probably higher in the US. And digging into that paper a little bit further, this is just to show the increase in nitrogen uptake for crops growing after legumes. So this would be for a cereal crop growing after legumes, either a grain legume, a forage, so a pasture, or a cover crop. So a few things, and this is the first year crop after those. So you can kind of see that I've put these in pounds per acre for you guys this time. You can see that the cover crop tends to leave more nitrogen, as you'd expect. You're spraying out all the biomass and leaving it in the field. You can also see the second crop, after the second crop is still getting quite a bit of value. It drops a bit for these grains and forage crops, but for the cover crop, it's really still quite healthy into the second year. So that's an increase in nitrogen uptake into that crop. So we're not talking about what's in the soil, that's actually being taken into the crop. And you can see that the increase in yield sort of follows that nitrogen pattern. I pulled out the data for wheat in the Americas. So this is going to be Canada, US and South America probably. So it's a bit of but kind of showing sort of similar thing, generally more after the cover crops than after the grain or forage crops, a little bit coming into the second year, not as much data for that. I don't know much about maize, but that seems like a lot of, I guess bushels per acre of maize are different to bushels per acre of wheat or something. The conversion factor was very different anyway. Those numbers are very high compared to the wheat, but I hope I used the right conversion. But it seems like a lot of grain for a fairly small amount of extra nitrogen, so perhaps the legume's doing something else. Anyway, have a look at that paper if you're kind of interested in nitrogen. So now the non-nitrogen benefits, and these include weed breaks, disease, and water benefits. So one of the big problems that we generated in Australia when we shifted to no-till was we created an enormous problem with herbicide-resistant weeds. The worst one is annual ryegrass. This is now resistant to every type of herbicide that exists, including glyphosate. So this has become a really big focus of management of farming systems in Australia. It's costing on average about $50 an acre to control that. 80% of that's on the things farmers have to do to control it, and 13% on remaining yield that's lost. And you can see even for glyphosate from an early stage, when we adopted no-till, it's just from using the same herbicides too much too often. And we've been doing quite a bit of work to understand how introducing more diversity into the farming system and combining that with agronomic procedures can get on top of a problem like this. And I'll show you some results from that. First of all, I'd point you to this, this weed management strategy, I guess. This is what's promoted in Australia. It's called the Big Six. So there are sort of 6 major ways that you can intervene to kind of to get on top of and keep on top of herbicide-resistant weeds. And legumes feature in several of those. So the first is rotate crops and pastures. Obviously, bringing legumes into the rotation adds diversity. And if you have a legume and a canola crop, we call that a double break. 2 years out of a cereal really allows you to get on top of a grass weed like ryegrass. Secondly, it allows you to mix and rotate your herbicides, because legumes have different herbicides that you can use to get on. So you're exposing the grass to different types of herbicides by having a different crop. And then you can also do some things with legumes. You can cut them for hay, you can brown manure them. We can also go in and spray top, like that means sort of go in close to harvest when the crop's starting to senesce, and spray to get on top of any weeds that are remaining in the crop. So there's a few things that legumes allow you to do in this kind of broader system of weed management that are really very handy. And we had a look at this a few years ago. We deliberately went into a field that had a seed bank, and this is ryegrass, herbicide-resistant ryegrass. It had a seed bank of 1,815 plants per square metre. And our question was, can we cost-effectively come in there and manage that down in a profitable way? And how do we do that? Do we have to buy our way out by using Roundup Ready canola and high levels of plant population and just spending a lot of money? Or can we introduce more diversity into the system and get on top of it that way? So we were looking at different canola options. This is expensive Roundup Ready hybrid. We use a lot of triazine tolerant canola, which farmers, it's open pollinated, farmers keep the seed themselves, so that's a lot cheaper. And then this one's resistant to both herbicides. So there's lots of canola options, but there's also legume options you could bring in order to try and keep on top of this weed. That's wheat with a lot of ryegrass in it, you can see there. And just to show you some of the results of that, so we ran that experiment for 3 years, and this is the 3-year financial results from running these different systems. So if you keep growing continuous wheat in the way that you have been, you'll just increase the ryegrass from 1,800 to 3,146, and you won't make a lot of profit. So that's just business as usual, just going broke. So that's not an option. You can go into the high input, stay in continuous wheat, go in the high input, spend a hell of a lot more money, make more money, but what you had to spend to make that money goes down, and you've still got appreciable ryegrass numbers at the end. Introducing canola by itself did take you a little bit further with weed control. You made a lot more money having that profitable canola crop in there. But one of the best options was this strategy with a lupin, then canola, then wheat. You get 2 years out of ryegrass. So you can see the ryegrass numbers came down to their lowest level with that diverse system. And you're getting 2 years of being able to rotate herbicides. You didn't make quite as much money, but you had, but your ratio of what you had to spend to make that money, so much lower risk here. And in the end, you had a better kill on the ryegrass. So this was an example of how we can bring legumes into the system to deliberately get on top of these herbicide resistance issues. And another experiment, this one was a little bit, this is a 4-year experiment, and here we introduced a diverse system which had vetch cut for hay. By cutting it for hay, you're basically taking all of that ryegrass seed off, and you're not getting any seed set that year. You're making a bit of money out of the hay. Then canola. The canola gets all the benefit from that legume before it, which is not taking nitrogen out of the field. Well, you're not taking seed nitrogen out of the field. And we compared that again with business as usual or an aggressive approach with more expensive inputs. And essentially it was the same story. Continuing on the same path, we went from 1,864 to 4,108, so just going out backwards. And this diverse system here did better than throwing a lot of money. So instead of trying to spend your way out of the problem, you can manage your way out of the problem, and diversity with legumes in the system really helps. And in this case, it was a hay crop, rather than a straight legume crop for grain. You see, we also adjusted a few other things. We changed the density. We hit on this one. We used more expensive pre-emergent herbicides, and we put more nitrogen on. So, they're all ways to try and get on top of weeds, but they cost money. And what about disease reduction? So these are a couple of the bad kind of root diseases we get in wheat in Australia. So this is take-all, this is crown rot. They both get worse if you're in continuous cereal systems. If you have a 1-year break, you can usually get on top of take-all, but you need more than 1 year out to get on top of crown rot. Its inoculum will stay in the field for more than 1 year. So again, this double break idea, if you've got an issue with crown rot, is a good idea. And this is some data sort of showing these are the levels of crown rot in the soil. This is a soil DNA test, right? So this is a logarithmic scale. So these differences are quite significant. We started the experiment with a very high level at this particular site. So this is one of my field sites. We started with this very high level. Where we ran a wheat, barley, canola system. So wheat and barley both host this organism. So you've only got 1 year out in 3 there, and you can see, it declined a little, but it's still in this kind of medium category. Even the wheat canola, so every second year a host, still pretty high. But when we introduced the double break, the chickpea, canola, wheat, we've really brought the inoculum levels down in 3 years into this sort of low population. So that's an example of how the double break can sort of very quickly get on top of an issue like that if you have that issue. Equally, if you can go in the other direction, this particular field started with a low level of inoculum, and we went into either continuous wheat wheat barley canola, wheat canola, or wheat chickpea canola, and after 3 years, the continuous wheat just exploded the organism. 2 years of host out of 3, still fairly high. Better in the wheat canola system, but the best system again is this double break. So another example of how introducing the legume as a double break helps with disease management. So what about the water benefits of a legume? Are there any water benefits? One thing we noticed in a lot of our work was that legumes do tend to have shallower root systems and don't use as much water. So often at the end of the year, if you go and measure the soil moisture down the profile, so this is the wilting point here, this is the field capacity here. If you look at what's left after all these different crops, wheat's pretty much dried the profile all the way down. This is field pea and chickpea. You can see those 2 legumes have left a lot more moisture all the way down the profile than what the wheat did. And to summarise that from a whole lot of trials over the years, we generally find that legumes might leave you 20 to 30 millimetres of extra water. So that's 1 to 2 inches compared to wheat or canola. Quite a big range. But the problem, so that's great. That's great. You might get a benefit from that the following year. However, legumes leave a lot less cover in the field. So this is what the field looks like over our summer fallow period. So we have very dry summer periods, and we like to sort of try to capture and store the moisture in that summer fallow as much as we can for the following winter crop. And you can see the legume leaves a lot less cover compared to canola or to wheat. And so what you find is something like this. So here's 5 different experiments, and that's the amount of water left in the profile after we harvested these crops. There's a legume in each experiment compared with wheat. So you can see that in all of those experiments, the legume has left more water in the soil profile down to 2 metres than the wheat. So that's great. That's a significant amount of water. Like that's a significant amount of water for our crops if it's still in the soil when we grow them. However, when we go back just before we plant the next crop, so after the summer, and we measure what the difference is then, you can see that pretty much it's diminished. And that's because the legume is just losing more moisture from evaporation than the cereal or the canola because they just cover the soil so much better in the summer. And so the effect on the following wheat crop, the effect on the following crops is sometimes it's not as big as you might hope when you see these numbers. Although sometimes there can be quite a significant amount left. So they can be useful in terms of water, but I think the nitrogen thing and those other things I talked about are possibly more important. Okay, so all of that was pretty good news, right? So why aren't we growing more legumes? And I've been through this kind of background. The problem with legumes is farmers consider them to be very risky, and a lot of these things are real. At a farm level, prices vary wildly with markets vary wildly. They all suffer from some kind of tragic fungal disease that will have the farmers out spraying 10 times if you get a wet year. You've got to store them because of this price going up and down. You really have to store them if you want to hit the market at a good point, and you need to find markets. They're not like wheat and canola where there's a ready market you can just deliver to. A little bit more work. So in my area, in that southeast corner where we don't have lentils or chickpeas, legumes represent less than 5%, and if it gets dry, they drop even further. So in my area, we think that one of the problems is farmers compare legumes just in the year they grow them. They look at the profit they get off the legume that year. They look at what they get off wheat and canola, and they go, never again, because they don't appreciate or they don't realise the benefits that are flowing through the system. So we decided to have a look at whether we could show what the value was of legumes at a system level rather than at a crop level to try and change this perception. And so we have been running these experiments. We're in the 9th year now, 4 sites around my area in southern New South Wales. And we're really trying to stack up all of the different system benefits, follow it over time and understand what's going on and whether it adds up commercially, economically. So the sorts of treatments we have different crop sequences here with a range of different legumes. I either call them high value, like human food legumes, like lentils or chickpeas, or lower value, or something like vetch that you can do a lot of different things with. And we're sort of comparing them with what the farmers considered to be their baseline, which is canola, wheat, barley. That's what they all said we currently do. We changed the sowing time, we changed the nitrogen strategy, and we did some grazing on some treatments. But these have been running for 9 years, and I just wanted to pull out some of the high-level results from that. These are the range of measurements we've been taking. That's kind of what the trials look like in the spring. They're quite big trials. Every crop is in every rotation is represented every year. They're replicated and phased, and there's a lot of measurements. I've marked the red ones that sort of go into understanding what the legumes are doing for us in terms of nitrogen, at least, and all that's been measured. These are sort of show you the 4 sites. I'm going to talk about these two together and these two together just to save time, and to indicate that these two, this is an alkaline soil, and this one was limed at the start of the trial. These two soils have a problem with acidity. So just keep that in mind when I show you the data, because that's an important point that's come out of the work. Just to show you that over the 9 years, these are decile rainfall numbers. Okay, so 1 means the driest 10% of years, and a 10 means the wettest 10% of years, and that is what we experienced at the 4 sites over the years. So we had 2 howlingly dry years, 3 very wet years, and we've finally hit some average years in the last couple of years. But no one can tell me that we haven't had extremes in weather over that time. So the data is pretty strong in terms of having experienced everything that the climate can throw at us. So I just want to show you now from one of the sites where the soil is neutral. Okay, so a good soil for growing legumes. We'd expect the legumes to be doing very well, and we were growing faba bean, which is a reasonably priced legume. It's not as cheap as lupin or pea. And this is the gross margin, the cumulative gross margin. Okay, over those whole 8 years, this is how the gross margin of the system, right, not of the crop, of the system has been growing. So the baseline system is always here in dark brown. And what you can see very clear, and the things that are green have a legume in them, and the things that are yellow are intense systems, which are just wheat and canola. The baseline, remember, is canola, wheat, barley. So what you can see at this site is that really right from the word go and through all those years, the systems that have faba beans are just more profitable, and they're holding that profitability all the way through. I think this is chickpea as well. So both of those legume systems have done really well compared to the baseline. So that sort of difference would really encourage a farmer to, and it has. The area of faba beans in this area is sort of really increasing. When we intensified with more canola and more nitrogen, we didn't really get our money back. Like in terms of the economics, that didn't work at this site. So that's a really good story, and this happened as well at one of the other sites. Conversely, at the Wagga site, now we're talking about an acid soil. So we grew lupin because it's adapted to acid soil, but it's not very profitable. And here you can see the baseline is just doing the best, right? We haven't been able to beat the canola, wheat, barley system that the growers said was their baseline. Continuous wheat, you can see down here, is certainly not doing very well. And you can't see the diverse one because these are all in a big pile. But either intensifying with more canola or bringing the legume in sort of hasn't made a whole lot of difference. The baseline is doing very well. Now that's partly because barley has been very profitable at this site. So that's one thing. And the second thing is that lupin, which is in the green system, is not that profitable. So that's the difference. So we're getting different responses at different sites, largely I think due to both the soil and what that means about what legume we can grow. Now, if you look at risk versus reward, so now this is, okay, this is the average annual gross margin, same numbers I just showed you, but it's plotted against the return on investment. So how much money did you have to spend? How much money did you get back for every dollar you spent? So it's a measure of risk, I guess. Where you want to be is up in this corner, right? Here, you're making the most money on average, and you're spending the least money to do it. And for the Urana site, which I showed you first, you can see that not only is it making more money on average, you're having to spend a whole lot. You don't spend as much, sorry, you're making more money for every dollar spent. So it's lower risk and higher reward, okay, compared to the baseline or here by intensifying with more canola and higher nitrogen, you really haven't covered your costs. You're just sort of economically going backwards. All right, so that's the Urana site. And at the Wagga site, it's different. At the Wagga site, now your baseline systems, are doing best in terms of average gross margin and dollars return on investment. Going to a higher nitrogen strategy didn't really make you more money, and you really spent more for no value. The legumes in the system are sort of not doing as well on average, and this group down here with continuous wheat are even worse. But this is a nice way to just present the data. It's from 8 years and it's at a system level, so this sort of information really the farmers kind of look at quite closely. I can tell you that, as I said before, the nitrogen value coming from the legumes is a big part of that advantage at the sites where the legumes are doing well. The fact that you don't have to spend money on nitrogen in the legume year, and then you don't have to spend as much money the year after. And as well as that, we were getting some yield kicks, presumably from disease or weed control as well. So that was a big part of the value of them. And you can see the numbers. The numbers are a bit higher here than what I showed from Mark People's sort of older work. So maybe we're getting better at growing the legumes, and they're fixing a little more than I showed before. So just to show you some results from the site that I manage, and it's one of the sites where the legumes have been doing pretty well. If you compare the baseline system, which at that site's canola wheat, with either intensifying to a canola wheat system or diversifying with a favour bean canola wheat system and different levels of nitrogen, basically you can see whether it's profit, return on investment, water use efficiency, amount of nitrogen you're putting on, nitrogen use efficiency, the percent of your gross margin you're spending on nitrogen, or even greenhouse gas emissions. Basically, that diverse system is kind of ticking all the boxes at that particular site. So this is the kind of information that we can provide to growers and to the industry to kind of demonstrate the value of these in the system, which may not always be obvious, in a single season. So that's a bit of summary of the outcome of that work to date. Yeah, it's a matter of growing the right legume in the right place, making sure that the legume's working for you. And nitrogen is not the only story. The weed story is a big one. And I'll talk a little bit about that now when I talk about cover crops and intercrops. How am I going for time? Going all right? Coming to the end soon. So, cover crops. So there's two types of cover crops that you could consider growing in Australia. There's a summer cover crop. So can you grow something in the summer fallow if you're concerned about soil erosion or in the summer? And the other is a winter crop, which I'll talk about next. Now, this is a review that I wrote a few years ago. This is what I think the response to a summer cover crop is. Okay, if in relation to all of these different aspects of the system, okay, comparing putting a summer cover crop in our summer here, right, compared to just leaving the residue, the crop residue as it is, in my view, if things go into the red, it means you're worse off. If they move into the green, it means you're better off. And my summary of mostly in Southern Australia, at least, putting a cover crop in over the summer is not beneficial in most cases. the summers are hot and dry. You can get pretty good cover from retained crop residues anyway, which is what most people are doing. It's hard to get a sowing opportunity because it's very dry at harvest, and you won't always get a rainfall event to reliably sow and get a cover crop up. If you do, the biomass might not be very high. So in terms of a legume cover crop, it may not do much for you. And more importantly, you're basically stealing water and nitrogen that would otherwise be building up here and used by the following crop. And that's probably the big issue. There are some tactical uses down here where I think there's if you've had a drought or you've had a crop failure, so you end up with very little residue, and you want to protect that soil, there's probably some circumstances in which putting a cover crop in does make sense, and then you certainly you'll move things. If you do it when you've got those triggers, you'll move things into a more positive sense. Anyway, that's summer cover crops. What's probably more common in Australia now is winter cover crops. So here you're basically replacing a whole winter crop, okay, with a cover crop. So instead of having a sequence of 4 crops like this and your dry summers, basically you're going to sacrifice a grain harvest by putting some kind of cover crop in here and terminating it in the spring. So the idea here is either cutting it for hay, grazing it out, spraying it out, but terminating it early, it gives you a much longer period to capture water and nitrogen for this following crop, okay? More importantly, you get a hit on all of the herbicide-resistant weeds by doing any of these things. And that started to make these winter cover crops look a lot more attractive to growers, driven by this herbicide-resistant weed problem, because that was a very critical problem. If you're in a high rainfall zone and you don't have herbicide-resistant weeds, it's really hard to justify this because you just don't get your money. You don't make enough money, and the opportunity cost of growing that is really not recovered, even with all the system benefits I talked about. If you're in a high rainfall zone and you don't have weeds, just grow a crop, So cover crop's not a good idea if you're in that situation. If you're in a very dry area, we have shown that here it can pay because quite often your crops themselves may not yield so much, and therefore the savings of water and nitrogen you can get from the cover crop can pay. So these lines here, in this area, there's sort of sandy soils and clay soils. I've drawn a line across at the amount of money you make if you grow wheat for grain. Okay, so that's what that line is. So anything that's above that line looks pretty good to a wheat farmer who might be thinking of diversifying. And you can see there are a couple of hay options there with vetch and with peas on both soils that look okay. There's other options here that are a little more profitable, but they're options in that system, and you just replacing this wheat crop with that break. So more likely to use it in a low rainfall zone. But if you have weeds, here is what happens if you've got herbicide-resistant ryegrass in year 1 here, and you run different scenarios. So if you run continuous cereal, you are just going to explode the herbicide-resistant ryegrass problem. Even with a 1-year break in peas or canola, it still drifts up. But these brown manure breaks or double breaks really keep the populations of the seed bank low. And that gets reflected in the profit that you make here. If you go into a continuous cereal, the herbicide-resistant weeds will just kill you, whereas all these other options continue to make money. And this is real farm data from a consultant. This is an advisor who'd been pushing this idea of brown manure peas, and everybody thought he was nuts because he was putting 25% of farms into brown manure peas, compared to growing wheat and canola or being in a mixed farming system with lots of pasture. I mean, this is still very profitable, but if you're in continuous cropping, and he basically showed with his numbers on a real farm that the profit or the gross margin was similar And that's because of all the benefits that I just talked about that this brown manure pea can bring you. One of the other benefits at a farm level is that if 25% of your farm is just off your hands in spring, you can concentrate on all the rest of the farm, get everything harvested on time. You know, it logistically on a very big 6,000 acre farm, that can make quite a bit of difference. And so vetch is also being used in this way as well. Intercrops. So I got pretty interested in intercrops. This is growing two crops together at the same time and trying to harvest them both for grain. There's a paper there that we looked into. I think the interesting thing to sort of pass on to you is that we think that legume oilseed intercrops probably have more prospects. And let me explain this graph here for you. Okay, so there's three different sets of data. Piola is a mix of peas and canola. And cereal legume mix is usually a barley with peas or wheat with peas or another legume. This is a summary of data from a whole lot of studies. And this is the one-to-one line here. So if your intercrop is producing more than one, then it's doing better than either of the monocrops by themselves. So you want to be above that line. And so you can see most of the intercrop data is. This is 1.5, right? So you're making 1.5 times more. You're 1.5 times more productive with the intercrop than with the monocrops. But what you can see with the piola, what this line is, this line shows whether you end up with a legume dominant situation or whether the cereal dominates. And you can kind of see that with most of these cereal legume mixes, you end up in a cereal dominated system. Whereas the canola, it's kind of the canola doesn't dominate the legume so much that you lose the legume in the mix. So we've been playing around with peas and canola. We also work on fabers and canola, and chickpea linseed's another one we're playing around with. I sort of got interested in this. Like, I know a lot of this gets done in developing countries, and but my question was, can you really do this at broad acre and really make it work? And I was stimulated by some of the results coming out of Canada. And I took a group of 20 farmers there in 2019 just to see how these guys are doing it. And there is a lot of logistical issues that you've got to get right. But anyway, the benefit of it, it's a way to get a legume into your system, again, working for you to build nitrogen. And most of the guys that we talk to, the over yielding that I just showed, that excites people sort of. That excites researchers, but what these growers are interested in, they want to reduce their input costs and they want to improve their soil health. If they get a yield benefit or an over yielding benefit, that's fine, but that's not what they go into it for. This is an example of one of my trials. This is on my long-term experiment, just to sort of show you a little bit of data. So basically, this particular year, I had an intercropping experiment because this strip is straight canola. This strip is straight faba beans, and this strip is a faba bean canola mix. And just to give you a quick idea of the outcome of that year, this is a pasture over here, so that's a perennial pasture. But essentially, the canola by itself yielded 3.3 tonnes, and it removed 140 kilos of N from the system. This faba bean here only yielded 2.3 tonnes. Basically, not long after that photo was taken, we got a very wet spring. This got full of chocolate spot, fell over, sort of just was a terrible mess. The intercrop with canola, the canola kind of held the faba beans up, reduced the disease epidemic. We only sprayed it once. We sprayed this 4 times, and it ended up yielding 3.8 tonnes of fabas with a 0.5 tonne of canola as well. Because we took off so much faba, we didn't leave as much nitrogen compared to this one, but you can see how that can sort of add up to something that's, you know, it's pretty attractive in terms of both yield and impacts on following crops. So we've got a wheat clover mix, I think, in that experiment this year. So we're still playing around with those mixes. All right, I'll finish up just with the future research ideas. I've lost a picture there. So where I want to go to from here, based on what's come out of that 9-year project, what we learned in that project was that almost everywhere in southern New South Wales where I work has this soil acidity problem. The soils are acidifying sort of in the subsoil, because of the no-till farming for so long, the line that we put on is really not getting down to depth, and that acidification is still going. And so the only way that you can fix that in our system, because we don't have enough rainfall to wash the lime in, is to actually incorporate it mechanically. So a lot of farmers are now doing that, fixing up that layer, that acid layer, and then going into the legume. But that's a very expensive process. And so I'm interested in that. If the farmer's going to do that, what kind of situation do you want the soil in when you do this? Like, what crop should you have grown before this happens? And what series of crops can you grow after you do this to get your money back as quickly as possible? So this sort of interaction between the deep soil amelioration and the farming system is what I think we will get into next. And there's a whole lot of implications of this on greenhouse gas emissions, soil organic carbon, soil health, profitability. So there's a lot to do. And up until now, these bits of research have really been separate in the Australian kind of landscape. Soil scientists have been doing this and agronomists have been doing that. I think it'd be good to bring it together. And then the other thing that's happening in Australia is that we're wanting to sort of, along the lines of those experiments, set up a network of experiments across the country that are looking at these systems questions. That's going to bring in a lot of digital technologies. And we do have people with those sort of skills now. And the idea is that if CSIRO, as the national agency, can have a network of long-term trials across the country, then when the government or the general public asks questions about, agriculture's report card on their sustainability or their productivity or their greenhouse gas emissions or whatever, we can give a good answer based on data from right around the country. So that's kind of what we're working towards. With that, I'll say thank you, and particularly to these two gentlemen here. Mark Peoples was the senior author on that legume paper. He spent his whole career looking at nitrogen fixation by legumes. And Tony Swan was his apprentice for many years and now works in my team. And yeah, these guys are the real legume experts. I'm a bit of a ring in because I mostly work for canola, but legumes are really good for making the canola grow well. So anyway, thank you for listening, and it's probably only half time in the soccer, is it?
Questions for John?
I'll ask a question. So, your intercropping work, which is of course, but
That's good. I saw your relay cropping at Belleville. So
yeah. So my question, are farmers in Australia interested in adopting relay intercropping? And you mentioned the driving force in Canada was more soil health and like other benefits beyond just straight production benefits necessarily. So is it the same for growers in your area, and just what would be the demographic or the type of farmer that would be interested in adopting this in Australia?
Yeah, it's a good question. In Canada, I can tell you, it's the very high end sort of growers, and many of them are just tinkerers with machinery. They built their own machinery to be able to sew the crops together. The biggest issue for them was separating the seed at harvest. So until they got that right, because they had trucks coming out of the field, they got to be able to dump the grain and get that seed separated and get it into separate silos, because they need to store them at different moisture contents. And that was the thing. I went there not even thinking that was an issue, because in Australia everything's so dry. When you harvest it, you can just stick it anywhere, right? And get it seeded whenever you get a chance. But yeah, that was their key issue. But they were very high-end guys. The other thing they'd done is they were growing high value things like maple peas and camelina and what was the other, chickpeas, and they had created a snack food business, right? And they were selling their own. They had a vertically integrated business making these snack foods out of chickpeas and things, and they could sell the story of how they grew them sustainably. And so yeah, they were very switched on guys. That was in one place. The other guy was into soil health, so he just He just wanted more stuff growing, more different root systems interacting. But he was in a very dry area where, you know, a lot of people would kind of say the intercropping's not going to work so well in those desperately dry areas. But he was in quite a dry area, and he was doing a lot of the chickpea linseed. You know, so I took 20 Australian farmers to look at it, and I've been trying to get our Grains Research and Development Corporation interested, because I think we just keep doing the same research on small plots over and over and focusing on complementarity and, you know, all of the physiological things. And we keep getting the same answer, and it's great. But that's actually not the barrier to adoption. The barrier to adoption are practical things on farm, and which is why we thought getting farmers involved. And, you know, we had an online Zoom with the GRDC and a whole lot of advisors who have growers who are interested in it, but can't get any advice and want some research done. And we talked for about an hour or two, and at the end of it, the GRDC guy said, well, I guess there's not much of this happening in Australia, so it can't be of much interest. So, you know, he was in a different meeting to me, because the farmers that were in the meeting were like really keen. So, but yeah, there's some hurdles. But like, as I say, there aren't too many. If you could get it to work, and obviously with robotics and automation and all these things that are coming along that might facilitate that kind of placing crops together and harvesting them differently. There aren't many technologies that come along in agriculture where you can increase yield, reduce inputs, and improve your soil all at the same time. And, you know, intercropping seems to be one, but we've got some logistical hurdles to get over. Yeah. The relay cropping, yeah, so the difficulty we have is we have this really dry summer, so you just can't do much in the summer, because we're just busy capturing and storing all the resources just to get the next crop growing. So yeah, I went to one of Chuck Rice's field days on regenerative ag over south of Kansas City, and saw a guy sowing a corn crop into a standing vetch that he then sprays out, grows his corn, then he sows rye and sprays that out, and then he sows soybean. And I thought, wow. And it clearly works in that system, you know, a lot of water.
Water helps.
Yeah, it does. It does, and it was brilliant to watch. Like, and because the field day was great, because if you told someone in Australia you can sow a crop into a standing vetch while it's green, like, they would think you were nuts. But they actually did it in front of us while we were, you know, like, it was brilliant to have that happening, because that, I would say, would be if you tell farmers that you did that, but they don't see it themselves, they possibly wouldn't believe that that's possible. And right beside that, they had corn coming up in the vetch, like, that was already planted about a month before. So kind of saw the whole system. So, but they've been at it for many years to get that right. And I think they're a set of brothers who are, again, very high-end sort of farmers who can manage that sort of technical stuff. Sorry, that was a very long answer.
Well, that was great. That's great.
So yeah, we have one question online. So Ted Hinton is asking, are there any opportunities for raising lupins as a biofuel crop or exporting the grain for feed in other countries?
As a biofuel crop.
Yeah, or for feeding.
Yeah. Well, to be honest, we have a bit of a moonshot idea about, because lupins are so widely adapted, and before it got too hard to control the herbicide resistant weeds, or sorry, too expensive, lupins was the one legume that you could grow pretty much everywhere. And we have a lot of oil chemists in Australia, and we believe if we could increase the oil content of lupin and have it create a canola type oil, it would be a fantastic sort of kind of a crop like you guys have got soybean, high value meal, high value oil. We would love one of those. So there's a little bit of that. That's a real moonshot. There's also been people looking at the lupin flower, because lupin, I don't know if you guys know, but like when they feed lupin to their rams in Australia, the male sheep, their fertility goes way up. So that they're kind of, apparently lupin flower, like lupin as a grain, has a really fantastic nutritional profile for humans, and a lot of benefits, but it's, you know, tastes a little bit different to wheat. And so I don't know whether we'll ever get people to kind of change their diet to that extent. Biofuel, I hadn't thought of. So I can't really answer that question. In terms of exporting it, a lot of it gets used just as sheep feed in Australia. The lentils and chickpeas, they're all exported as a human food. I don't have a good answer to that question. I'd have to ask somebody who knows a little bit more about international markets for lupins. But yeah, a lot of it gets used domestic. Most of it gets used domestically. In fact, a lot of it just held on farm to help feed sheep. Like in the dry summers, farmers will sort of keep it as a sheep feed to avoid the, you know, for drought food, or sell it to other farmers for that purpose. But yes, if we can increase that, so any way we can increase the value of lupins and get it back on a bigger area of ground would be really great in Australia, because it's so widely adapted.
Thank you.
So John, regarding the nitrogen contribution, right? I think that you had a table that when you're harvesting for a grain, you could go from negative to positive, right? A pretty big range there. How often, if you're harvesting for a grain, is it going to be on the positive?
It's mostly on the positive. The average would sort of suggest that. The negative is something like lentils. Like if you grow lentils, they're about this high. They produce very low biomass, but they have a pretty good harvest index. So you take a reasonable amount of grain out of the field. So it's those kind of small growing legumes where that happens. And if you grow them and they're not fixing for some reason, if you've got acid soil, or, you know, that's where I would say they're running into those negative numbers, is where you've got a small statured legume that hasn't been fixing very effectively. So essentially it's just like cereal or something else. It's just sitting there taking nitrogen, and then, you know, it's got a lot of nitrogen in the seed, so you're taking quite a lot out of the field. So that's where those negative numbers are coming from, I think. Yeah.
Because if I'm not mistaken, we're not counting with too much credit for soybeans, right, in this region. I think that we used to, and then we kind of changed that more recently. And there's even some studies showing that higher yielding soybeans actually, they're taking off a lot of nitrogen. They're not producing at all.
Yeah, I haven't got much, but
Really, soybeans that there's field ceiling with expectation only that had inspection
Okay.
actually give you a boost on the soybean.
Yeah.
But yeah, there's been discussion of nitrogen credits. I would not be the person to answer the nitrogen credits question, but I think that there has been some work and some thought of revisions to those here.
Yeah.
If I'm not mistaken, we used to consider about 40 pounds per acre as a credit, if I'm not mistaken. And then we're not using that number anymore.
Yeah. So have a look in that paper of Mark Peoples, because he's done Americas, and particularly in maize systems, but wheat systems as well. So soybean, and I think soybean is the main legume, right, in that system. The other thing Mark's done a lot of work on is understanding the below ground contribution, right? So we say 20 kilos per hectare per ton of above ground biomass, but Mark will say you'll get 40% again that's below the ground in roots and nodules. And he's done some pretty painstaking work with students to get those numbers. But he works through it all in that paper. So maybe have a look there, see what he's coming up with. Or papers that he cited in there. I could have a look at that. We don't grow much soybeans. So. But yeah, I guess if you're pushing the yields up and not increasing the biomass, like if they've got a higher harvest index, if that's what the breeders are doing to soybeans, then it's probably starting to chip away at the value that you're getting. Or I wonder, like in your systems, your soils are so much more fertile than ours. If you've got high nitrate in the soil already, the legume doesn't fix as much, right? They're lazy. So if your system is such that you're on fertile soil and it's mineralizing all the time, and they come along and there's already 150 kilos of N sitting there in the soil, they'll just take that up first before they'll, you know, it switches some legumes off. So whereas we don't have that issue. But yes, I'd love a soybean. If it's adapted to Australia, that'd be great. But we just, yeah, they don't like the cold of our summers. Our summers are not warm enough. Our summer nights are not warm enough. We do grow a bit in Queensland. I shouldn't, but and that's really specialised for what's the stuff called? Is it edamame or? But anyway,
Yeah.
Special, very special markets into Asia that they grow soybeans in Queensland. It's quite small. It's quite a small area. I think we should let these people go, Lewis.
Yeah. No more questions. Please don't be shy also, Doctor.
mentioned lupins, you select the fava beans used.
Mainly stock feed as well. Yeah.
Forage value, or is it all just?
Mostly just for grain, but we have wondered whether we could do a dual purpose fava bean, because that would be interesting. But the fava bean, I think, tends to go to dairy farmers or to a different sort of livestock end use, and so it's a little bit higher value than lupin. A lot of the lupins just kept on farm or sold locally for sheep. But I think the fava bean ends up mostly livestock. Look, there may be some human food uses of it. I'm not sure, but I think the prices are not as anywhere near what you get for lentils or chickpeas, which are both, you know, sold as human food into India and Bangladesh and places like that where they eat a lot of pulses. So again, yeah, if we could find a higher value market or produce a fava bean that had a higher value like that, that would really change the equation a lot in terms of the value. Because where they grow lentils and chickpeas, they're just a mainstay because they're so profitable. In fact, we've got to stop farmers growing lentils after lentils and chickpeas after chickpeas because the prices are so good sometimes that they're tempted to do that. But the fungal diseases that those crops suffer from would suggest that wouldn't be wise, but you know. But it's tempting when it's $2,000 a tonne or something like that. It's compared to 300 for wheat. And that's the prices get crazy sometimes when the markets are good.
So no more questions. So, okay. I'd like to thank you, Dr. Kirkegaard, for sharing your knowledge with us, and thank you everybody for listening. So Dr. Kirkegaard.
That was the incentive.
Yeah.
Well, Rachel might come.
Yeah,
and-
yeah.
Thank you.
But anyway, yeah, so early July, we can do that, and if the wheat is off, then we could still go out and look at our stuff and talk about that also, because we have a couple different configurations and a couple different ways that we're setting it up and trying some different things, so, yeah, but yes, for sure.